it is in the US customary system because feet are given. The thin plate is fully submerged in water, so we position the coordinate axis so that 0 is at the water level still. We slice the thin plate horizontally. The depth of the slice is yi as before. The thickness is delta y. Thus, the force on this slice is now the weight density times the depth times the area, which is delta dA. Notice that rho g is being replaced by delta because the units are in feet. The depth is yi, and the area of the slice is the width L of yi times delta y. It remains to find an expression for L of yi, but we notice that the width is twice the horizontal leg of this right triangle. This horizontal leg is half of the width. The vertical distance is 7 minus yi. The radius is 5. In this right triangle, the vertical leg is now 7 minus yi. The hypotenuse of this right triangle is the radius of the circle, which is 5. And using the Pythagorean theorems, we have x squared equals 5 squared minus 7 minus y, the quantity squared, which is x squared equal 25 minus 7 minus y squared. So x is the square root of 25 minus 7 minus y, the quantity squared. This x is half of the width, and so the width is 2 times the square root of 25 minus 7 minus y, the quantity squared. Thus, the force on the slice is delta, which is the weight density. The height is yi. The width is now 2 times the square root of 25 minus, open parenthesis, 7 minus y, close parenthesis, squared, times the thickness, which is delta y. The total force is the sum of the forces on n slices, the sum as I go from 1 to n of 2 delta yi, the square root of 25 minus 7 minus y, the quantity squared, delta y. This is the Riemann sum for the total force. As n goes to infinity, we obtain the definite integral. 2 delta is a constant, so we move it to the front of the integral sign. Y times the square root of 25 minus 7 minus y, the quantity squared, dy. For the limits of integrations, we add up the slices on the thin plate only, so the lower limit of integration is 2 and the upper limit of integration is 7. Evaluate this definite integral to obtain approximately 11,972.25. The unit is pounds. In this computation, we use the weight density of water, 62.5 pounds per cubic feet. But if we were asked to use 62.4 pounds per cubic foot, the answer might be slightly different.